We're delighted that you all are here today to join our Tactile Graphicacy webinar series. This is part 2 of a 3-part series um, focusing on teaching students to read and interpret tactile graphics used in math. This is part of a major initiative where we're spearheading with some of the instructors on today's course through the Tech Equity and Access in Math Initiative, which is a committee of like-minded folks who love math and love making sure our students have access to it. So without further ado, I want to hand the reins of this webinar over to the folks who know all about this, Sarah Larkin and Tina Hertzberg, both of whom are members of our team initiative. Welcome aboard.
Thank you very much, Leslie. I'm Sarah Larkin. I am the statewide math consultant in Iowa for the Iowa Educational Services for the Blind and Visually Impaired.
Hi, I'm Tina Hertzberg, and I'm a professor and coordinate the Visual Impairment Education Program at the University of South Carolina, upstate. And I'm very excited to be here with you and Sarah tonight to talk more about tactile graphicacy. So our objectives for tonight, that by the end of this session, you will be able to describe at least 3 common mistakes students make when reading and interpreting tactile graphics in math. 2, strategies students can use when reading and interpreting tactile graphics in math. Actually, I hope it's a lot more than 3, but at least 3. And then resources and strategies for teaching students to read and interpret tactile graphics used in math. And, once again, I hope it's more than 3. And as a matter of fact, I can't wait to learn from some of you that you may know of other resources that you're willing to share with us as well. So tactile graphics and image descriptions. So in order to use image descriptions, you really have to have a solid conceptual development as well as know how to read and understand tactile graphics. Because otherwise, if you're just going through a image description, you really have to put things together. And if you don't have that background, it's really difficult to use that information. And as a matter of fact, sometimes it's, if not difficult, almost impossible. So math concepts learned or assessed through tactile graphics can't always be learned or easily assessed through other mediums, such as image descriptions. And we're going to see a couple of examples later on that realistically, real objects and tactile graphics, very different than putting it together with an image description. And so I think to me, the real key with image description is that students have to have this mental mapping of the provided information, and they have to be able to sort through that information and make sense of that, which is even harder when it's only in auditory form. So what about digital math? Because that's what we're here to talk about today. So tactile and auditory information are not identical. That we have either an image description or perhaps we hear a graph, we get some information, but we may not get the exact same information that we might be able to get from a tactile graphic. And so the one thing that I have become, I think, increasingly aware of is that you really have to provide direct instruction of how to use image descriptions, because otherwise, if we give students image descriptions on assessment, but we've never taught them how to use them, they really don't know what to do with them. And matter of fact, they may not even use them. Wasn't quite finished with that last slide. Sorry, Leslie. So it doesn't necessarily need to be one or the other. So sometimes, though, it actually works really nicely is, let's say that we have a tactile graphic, but then to simultaneously be able to also listen to it and hear an image description, that sometimes they work really well together. And especially when we are teaching a new concept to a student. But in contrast, sometimes on assessments, pairing them together may not always work well. So then the other part, because y'all, our landscape, our technology landscape is really evolving. that now we have more full-page refreshable braille displays than ever before. And so then what we also, though, with those is that it's not the same like number of lines. And so even with a full page refreshable braille display, it may only have 10 lines of braille. And so we have to like consider that. How is that going to change the tactographics and what we're able to provide in a tactographic with a more limited space? So don't have all the answers yet, but it's an exciting time to be here to kind of figure those things out. So I think image descriptions, I think refresh braille displays, especially multi-line ones, that we're evolving. And even this conversation in 1 year might look very different. It's an exciting time. So let's talk a little bit about basic or very simple graphics. And so we have our first image, and it says 30, which 3 shapes are quadrilaterals? And then it's followed by 6 choices with different shapes. So the first thing we'd have to think if we had an example like that or a test item is that what were they actually trying to assess? Because if we were going to try to like create an image description, we don't want to give the answer, but then we also don't want to change what's required of the student. So let's just say that perhaps I had said, oh, like pentagon, hexagon, and I'd actually like given the name. Well, that's actually probably a very different thing to assess, because with these images, even if students are like, oh, quadrilaterals, oh, 4-sided shapes, I can count them. That is a very different skill than remembering, oh, a hexagon has 6 sides and a pentagon has 5 sides. So we're not necessarily like assessing the same thing. So if we are using image descriptions, are we still getting at what we wanted to assess? So sometimes that's really kind of difficult to know what is being assessed. And so that's sometimes like working with math teachers. So because we don't want to give the answers and we definitely don't want to make it a different item to be assessed. And that's just for the basic and simple ones. Sarah's going to share a little bit about more difficult graphics.
Yes. So obviously there's that end where it's very basic, and therefore any image description might give the answer away. And then we have the other end where we have very advanced graphics. And then we're ending up in a level of cognitive load that can sometimes go beyond where that student is able to comprehend and bring it all together. It also can change what is actually being assessed. Um, does it match the language being used by the teacher? So sometimes those assessments are using different language than what is being used in the classroom. Here's an actual image description of a graph that I have shown on the slide. The image description says the title of the graph is distance traveled by Tim. The x-axis is titled number of hours. The axis has a range from 0 to 10, increasing in increments of 2. The y-axis is titled distance miles. The axis has a range from 0 to 250, increasing in increments of 50. A solid line with 5 points labeled is on the graph. The line begins at 0, 0 and passes through the points 1, 50, 4, 200, and 5, 250. The line continues. So imagine if I did not have that tactile graphic, or if I was just relying on that description, am I able to put that together and answer a question about that graphic on top of it? Now, that actual image description that I have there also, even if I have a Braille display attached to this, it becomes more of a reading assessment as opposed to an assessment of how they're reading the graph itself. One of the things we want to assess with students is whether they can really interpret the graph. But when we are just giving them the information that's on it, there is not necessarily an interpretation that's going into that task. On the next slide, we actually have some assessments and checklists for you. Because one of the things that's important to do is to look at what are the skills that your student already has a handle on, That way you're not spending time teaching those skills they already have. It can really focus on bridging the gap between what they do know and what they still need to learn. So it's nice to have a few different options out there. First of all, APH Foundations for Tactile Literacy has some lists within that particular document, and we have linked to that document right on the slide. So it has some lists of some of those really early skills. There are also two assessments available through APH. One is the BOEM 3 Preschool Tactile Edition Kit, and then there is also a BOEM 3 third edition that's for grades K to 2. And that actually has a data collection sheet. It has a script that tells you what questions to ask the student. It starts out with real manipulatives and then goes into the actual tactile graphics. There is also Maryland College and Career Ready Standards has listed, they have a section in their document specific to tactile graphics. So they've listed by grade level those common graphics that happen at each grade level. For especially those younger students that are in preschool to age 6, the Oregon Project within the cognitive, the compensatory, and the fine motor sections, there are lots of tactile graphic skills within that. And some of them are pre-tactile graphic skills and some are the actual tactile graphic skills. So the Oregon Project also has, besides checklists to work from, it also has activities that help support some of those skills. The next bullet we have is the TSBVI eval. So if you have access to the evals kit, there are two sections that will help with those that listing of tactile graphic skills. One is pre-braille, which has a lot of overlap when it comes to tactile graphics. And then there's one called TG Math, which is a shortened version of tactile graphic skills for math. And it's really nice because those are laid out by grade level as well. The next thing we have in here is the TSBVI Early Tactile Learning Profile. We've linked directly to that PDF document. And so there's a lot of information around both the skills and teaching those skills as well. The last bullet, unfortunately, is APH Tangible Graphs, which has been discontinued by APH, but we have decided to include it here because there are some of those EOTs that still have access to those kits. So you can always check it out if they have it available for you. So one of the things that often comes up when we're talking about graphics, tactile graphics specifically, is the 4 E's by Harrell. There are 4 key elements that we need to look at. The first being exposure. Exposure has the student, you look at, has the student encountered that particular type of graphic before or not? If they have, then they're going to have a better idea of how to access and work with that particular type of graphic. If they have not had exposure to it, then that's where that direct instruction on how to approach that graphic is important. Secondly is experience. How often has the student seen that type of graphic in order to make associations with it? Oh yeah, this type of graphic, I need to make sure I look for a key, or I need to make sure I look for a title, or I need an anchor point. So experience with those different types are real important. Exploration, when they are accessing the graphic, how efficiently and effectively are they doing it? Is it random? Or are they being very specific about what they are exploring and when? And of course, enthusiasm. The more success they have, the more enthusiastic they will be in using graphics in the future.
So there are a number of instructional materials that are also available. Some of these are from the American Printing House for the Blind, and some are not. But here's just a few. And the first one is actually probably one of the most underutilized resources that we have, and that's the like classroom materials, including like their textbooks. Now I know that in today that we see fewer and fewer textbooks, but there's still a number of them. And if they have graphics, that's a great resource for teaching our students about the different types of graphics that they are going to encounter in math. And the nice part about that is not only are they the types that they're going to be seeing in their math classes, we don't even have to create them. I don't know about you. I love that. We're previewing it. When they get their math, our students are like, yes, and they're feeling really confident. There are a couple of kits from APH, the Teaching Touch Kit and the Tactile Treasures Kit. And so I will tell you that with the PowerPoint, we put each one of these, the links. So in case you are interested in learning more, you can directly go to the link. Another one is the Animal Watch Building Graphics Literacy. So this is actually an iPad app, and with it, that it teaches students about how to read, interpret graphics. Now, the good part is that the app is completely free. The bad part is that you have to pay like 300 and something dollars at the Lighthouse for the Blind. I think it's in San Francisco to actually get the graphics. But I will say that they have such a diverse, really high quality graphics that I think it's well worth it. And so I will tell you that maybe that's one of those things that even like if you order them, that maybe could be shared. So maybe like 2 school districts might be able to share a copy or something like that. The flip over books, which many now are available, like parts of a whole, textures, line paths, and then there's fractions and telling time available both in Nemeth and UEB. So excited to see more UEB technical or UEB math resources. So the setting the stage, it's another one of those APH products. The kit's discontinued. However, you can still download the guidebook, and it has a lot of great activities that you can use with your students. And then the APH tangible graphs are discontinued, but hopefully some of you still have them, or you know somebody who might have them. And somebody was just putting in the chat that they're thinking that APH may be updating tangible graphs or thinking about it. So maybe if they get at least, I don't know, let's say 10 or 15 emails, maybe that'll encourage them to reproduce it. So this is your opportunity, because we really want to hear from you too, and all of your great ideas. So what are some of the advantages to using the students' classroom textbooks or materials when providing instruction on reading tactile graphics? So think on that for just a minute. And then when you think of something, what are some of the advantages? Because I gave a couple, but there's a lot more, y'all. So what are the advantages to using materials from the classroom when you're providing instruction on reading tactile graphics? Oh, we got our first one, accuracy. Oh, so they're receiving graphics. Oh, they're using graphics, the same ones that the other students in their class are using. Participating in real-time instruction. I am loving this. Students receiving graphics that they will be using in assessment, so it's not going to be new. Love it. Classroom discussion. The other students have the same material. There is such advantages to our students having the same materials as their peers. I am just loving this. Anybody else want to share with us? Some great consistency. Increases exposure, real-time help and instruction. And I think that's true, because especially that if we notice, let's say that there is like maybe an area of struggle, or perhaps that we notice that they didn't notice the key, this helps us really to be able to target that instruction. And then the very positive part about it is when they're using those graphics in class, they're ready to go. They have the same information that everybody has, and they're able to access that information. Materials are leveled appropriately. Love it. So thank y'all for sharing with us. If you think of more, even while we move on to the next slide, put it in the chat. We'd love to hear from you. And at the end of the session, in the coming days, that we will be collecting everything in the chat and sharing it back out. So if you're like me, I've already gone to the one from last time. It's like, ooh, there were some couple new resources that I wasn't overly familiar with. I was like, I got to check those out. So I hope you'll think the very same. So these are just some general considerations for during instruction. Now, the number one is, I think, really important. We have very little research about tactile graphicacy, but what we do have, I think, is really important. So Kim Zebahazy and Adam Wilton in their 2021 is what they were able to determine that students that have received formal and specific instruction were more proficient and efficient. This does not surprise me in the least, that when our students are exposed, that they're given direct instruction, they benefit from this. This actually helps them become more efficient and more proficient in using tactographics. And so with that we need to introduce tactographic skills at a young age. If you were here last time, that, we had it was like a circle, pink kind of fuzzy on a Cheerio box. And so that, they could figure out like which cereal is the one they like. Oh, that's my cereal that I like. That we don't have to wait till they even enter school, that we can be like giving parents some tips. And when they're entering school, is to introduce them to very simple ones, and so that they're just always exposed to them and they never like really seem hard. They just progress with them as across time as they get older. And this next one that I think is super important is that you model how you would approach a particular graphic. So if I was going to read a pictograph, I would use a very different strategy than if I was going to read a Venn diagram. And so we want to kind of model that. We want to talk through about how we would approach it. And that kind of helps our students to have some ideas of how we approach it and the things that they might want to do. And then when we're modeling, we're talking to ourselves. I do great at this one only because, hey, I'm always talking to myself. So yeah, it's just like, this is what I'm doing. This is where I'm moving my hands. This is why I'm doing it. Oh, this is where those two circles in the Venn diagram, they overlap. That means that, wait a minute, that means that, oh, so both frogs as well as snakes have these features in common because these circle overlap. That's what tells me that. That's super important information. And then we progress from simple to more complex. And that this is one thing that it really is building from part to whole, that when you're exploring a tactographic, it's putting all that information together. And how does that fit together? It's almost like putting together a puzzle. And at the very end, it all makes sense. And that's what we hope it is. And so as they're exploring, they're putting things together, making that mental map of it. And then it also helps to increase memory for location and spatial awareness, like where certain elements are in relationship to the other elements. So lots of just some general tips for instruction. So early learning skills. So a lot of times we're talking like kindergarten, that they may have where it says 5 fans. And then below that, it has 3 fans that are more of a like traditional, I think, like fan shape. And well, I'm not even sure that I would say they're more traditional, but I don't know, like a folding fan almost. And then the other ones remind me of a ping pong paddle, but they're supposed to be a fan. How I guess you could fan yourself during a parade. And so what the students are asked to do though is to be able to count. And so even though there's like 2 different shapes within that, is to be able to realize that there are 5 total fans.
Leslie, could you go ahead and forward through those bullets? Perfect. Thank you.
So what kind of early learning skills? Oh, wait a minute. Oops. So going back to the early learning skills. So sometimes it actually is just like counting. And sometimes it's like we're counting buttons on a page, or maybe we are counting fans. Sometimes it's we're sorting, because this one, even though it really may have been designed for counting, I can promise you that we're going to kind of sort and we're going to compare these. And we're going to distinguish between same and different, because we want to start with things that are really, really different. and then move to more refined differences. And so this is a great example of something that's quite different. So it might be classification. Which of these are butterflies, and how will we know that they're butterflies? Maybe it's that we're going to group by shape or texture because there would be different textures. And then this last one I think is so important, is that recognizing objects in different location, different orientations. So what we mean by that, that if we have a right triangle, we're going to see it. I think it's on the next slide. It's not on the next slide. Okay, so I'll just talk through it. So if we see this right triangle, that we need to see where the hypotenuse and the legs, where they're in different orientations, so that they recognize that it's a right triangle and what are like the elements that make it a right triangle, regardless of the orientation. I have seen students, even like in middle school, that really kind of throws them, that it doesn't look, and I'm going to put that in air quote, that the shape doesn't look like they think it's going to look, and that kind of throws them from recognizing what it is. And so that's really important, that when we are drawing like or introducing like triangles from a youngest age, that we don't always draw them the same way, that we draw them in different orientations. So we also, when it comes to different types of lines and shapes, we want to move from simple to complex. So horizontal or vertical lines, curved lines or diagonal lines, because this may be different than they're accustomed to seeing when they're reading Braille. Outlines of a basic geometric shape. So they have a matching activity where it has the word as well as the shape, where it's made with just the outsides edges of the shape with wiki sticks. And then they have to match it to shapes that are not just the outsides, but the complete shapes, to realize that they're both representing a circle or they're both representing a rectangle. And so as that our students get older and as they are progressing through their math, that we want to keep on introducing them to more complex, to like, from going from 2D shapes to 3D shapes, such as a prism or a pyramid. So I will tell you, on the very bottom, there are it's a 3D rectangular prism that are composed with cubes. Now, the really cool part about that are these cubes, y'all, are part of the Stack Up. I don't know if you're familiar with them, but it's a great product from APH. And it's just amazing how much like spatial reasoning that you can teach with using the Stack Up cubes. So if you haven't checked them out, that might be something to check out. We're going to have the link to it later on in the PowerPoint. So if you're looking for, let's say, more information about putting the parts of a graphic to whole, Lucia Hasty has put together several videos that are outstanding. And so we wanted to go ahead and share the link, actually the links with you. And so that way you can check them out. Leslie, we're ready to go to the next one. As a matter of fact, I'm going to turn it over to Sarah as we do.
All right. Thanks, Tina. So one of the important things, one of the important skills is that students be able to identify how those parts of a graphic relate to each other. And one of them is using that idea of height or length or width. They should start with even just being able to line objects on a cookie sheet or a tray of some kind. So they understand the importance of that left side or that bottom being at the same location before they can figure out whether something is taller or longer or shorter. Now, it's also more advanced when you go beyond two items. So taller, longer, wider, shorter is an easier skill than tallest, longest, widest, shortest, because now you're talking about more objects. And so that's going to take relating more than just those two objects. When you're doing fractions, though, being able to count how many parts it's divided into and then how many might be shaded or unshaded is an important skill. I have a graphic on the screen related to perimeter and area. It is an irregular figure. Sometimes we forget about going beyond just basic shapes. to shapes that are irregular. It's kind of like a print L, like a black L. But in this particular graphic, not all of the sides are labeled. So it is important that the student look at the segments that are going the same direction. For instance, at the top of the figure, there is 3 meters. There's a horizontal line that's 3 meters. Towards the middle of the figure, there's a horizontal line that's 2 meters. And then the very bottom is not labeled. But they have to use the 3 meters and the 2 meters to figure out that the entire length along the bottom is 5 meters. So that importance of which direction those lines are going and which pertain to that longer segment is important. Similarly, on the left side of the figure, the entire height is 7 meters. And then on the right side, there is a section that is 4 meters, but the other part is unlabeled. So they would have to use that whole being 7, part being 4, to figure out that the other part is 3 meters. So being able to relate the positioning and direction of those segments is important. I also have some volume cylinders. One is a smaller, not as wide cylinder, but it's taller. And the other is a wider cylinder that is not as tall. It's the same amount of liquid in each, but even experiencing liquid in those two models to show that even though we put the same amount in each cylinder, that one that is not as wide is going to go up higher with the same amount of water. If I'm doing the pan balances, the idea that if they are the same height, that those are equal masses or equal weights. If instead one side of the pan balance is higher, that part that's higher is actually lighter. The part that is lower is the part that is heavier. So including some of those concepts in your description. The last picture I have is dealing with density and the closeness of molecules. So we have solids, liquids, and gases. The first one, in gas, the molecules are spread out. In the liquid, they're a little closer together. And then in the solid, they're really close together. So that idea of how close are those in relationship to each other is important. Right, and go ahead, yep, and forward through those. So length, shape, and size. When I am looking at a concept, you always want to start again with the easier skill and then build on it. So make sure that you are maybe doing the same shape, but different sizes, or the same size, but different shape, before you get into changing 2 features of an object. Start with just changing 1 feature. Also looking at similarities and differences and verbalizing what those similarities and differences are is extremely important. When you're talking about acute, right, and obtuse, that idea of how much space is between those 2 rays that form an angle is really important. And then, of course, 2D is often easier to manage than something that is a 3-dimensional object on a 2D plane. Understanding the length as a tool, how can I use my fingers to compare lengths? Maybe the width, this is 2 finger widths or 3 finger widths long, to compare maybe that length. Consider having real objects and then tactile lines representing those objects, and having a discussion about which tactile line would represent which object based on its length or height. And of course, asking the question about why. Be sure not to end with just a yes/no question. Use those open-ended questions and get them using the vocabulary as they're exploring. Paper folding, if you don't have a lot of time to plan instruction, this is one place where it's really easy because all you need is paper for some of those basic concepts. So I could take just a regular 8.5 by 11 sheet of paper, and I can make just by connecting the bottom with the right side, I can make a square shape out of that and rip off the extra. And then I have that square, when I open it back up, is now divided into halves. So you can do fractions very quickly. I can do halves, or I can fold it a second time, and now I folded it into fourths, and opening that back up and counting those pieces. I can use a parallelogram, just a paper that's a parallelogram, and I can divide it into rectangles and triangles to talk about the area. Diagonals of a quadrilateral are really easy with folded paper in that I can just fold along where that diagonal would be, open it back up, and allow the student to trace those diagonals. The height, to make that height, the idea of folding it so that the bottom goes on top of itself but passes through one of the vertices, is going to help them produce that altitude. In the process of producing that, that's going to help them understand the concept of what height means. Parallel lines and perpendicular lines are another thing that's really easy to place just those folds on using a piece of paper. Intersecting means instead of them going the same direction, they're actually going to cross somewhere, but they don't always cross at right angles. So what that difference looks like. I can even take a paper plate, which is in a circle, and I can cut in a radius or a diameter or a chord and explore what those look like as well. We talked a little bit about acute and right and obtuse angles, so we'll go ahead and move past that one. And vertical angles, if we just have two lines that intersect, those vertical angles are those opposite angles that are the same measure. All right, we'll go ahead and look at the next slide. So scanning the page. Do you want to take over that one, Tina?
Absolutely. So the next few slides, we're going to talk about scanning and systematic exploration, as well as other techniques. So the first thing we really want to encourage is whenever possible, it's very helpful if our students use both hands to explore. So when they're using both hands to explore, they're able to get additional information. So first of all, it's even like the size of the graphic. What areas of the page include like part of the graph? What type of graph on the page? So that to me is as soon as I know that, oh, wait a minute, that's a bar graph, that helps me know how to explore. So I love just like 10, 15 quick second just scan of the page. And if I can figure out in that short period of time or even a little longer what type of graphic it is, it makes my role as a reader much easier. And so I'm really like encourage my students along the way is, hey, let's see if we can recognize what kind of graphic this is, because that's going to help us know how to explore. So once again, what is the size of it? So there are tons of graphics. Matter of fact, the last bullet is and even more, because there really are so many more. So Sarah's talked a lot about these already with the 2D and 3D shapes, including fractions, bar graphs, dot plots, circle or pie graphs, coordinate planes, scatter plots, line graphs, histograms, number lines, measurement, pictographs, subitizing. So that's like 10 frames, base 10 blocks. That's any time that we can like immediately like recognize like, oh, wait a minute, it's a 10 frame and there are 5 markers or tokens, then I know automatically I have 5 and that means if I had 5 more, I would have 10. Venn diagrams and much more. So it is really important that we have a systematic search, because depending on what kind of graphic. Okay, so we have a real quick question. I think we can get to this very quickly. So do you have a suggestion for how large a graphic should be for optimal scanning? So does it depend? I do think it does depend, but from what I've read in like the Braille Authority of North America's tactographic guidelines, not Tina's, but Braille Authority, is that they suggest that it is like 2-hand size. And so whenever possible, you really want to kind of stay where, like, if you think about like the age of your student, their hands might be a little bit smaller, but can we kind of keep it within that range? Doesn't mean it always works out, but that's if we can is really helpful. So do we want to have a vertical or horizontal or circular search pattern? So vertical actually is often the most efficient because there's fewer sweeps to cover more area. Students should also use, once again, both of those hands to get like an idea of what area on the page, what do they include and what type of graphic it is. And then you really want to and sometimes it's like, okay, we figured out what kind of graphic this is. Talk me through how are you going to really, let's say that you're in class and you only have, your teacher's going to give everybody just like 30 seconds. What are you going to do to really efficiently make good use of that time? How can you get the most information in that short period of time? And then go to that key information for that type of graphic. So we double star this because we think it is a double star item that really every bit of time we spent on helping our students develop systematic search will pay off dividends for as long as they read Tactile graphics. So I was thinking it was flood the chat time. So we were just talking about a number of different types of graphics. So it's important for students to be able to use their tactile discrimination skills to identify kind of landmarks on a page. What are some of the landmarks on these type of graphics, y'all? And so we have 6. You get to choose. So maybe you want to write about what should they look for about geometric shapes? What should they look for? What are the landmarks on bar graphs? How about clocks, number lines, circle graphs, and dominoes? So first of all, to start your response with, like if you're doing shapes, put shapes and then tell me what are the things that you're teaching your students that you want them to really target? And let's see if we come up with some similarities. Dr. Koenig taught me to make a graphic no larger than 2 hand spans. Oh, he was my original Braille teacher. Oh, just saying the name just feels good. Thank you for sharing. I totally agree with him. So how many points? I'm guessing that how many points? Wow. Oh, that I'm guessing that's a number line. We'll see. Number line starting, number line ending number. How many points? Very good. So we have a couple of people that are getting strategies for number lines. This is great. Anybody else? Bar graphs, axis and labels. Absolutely. And even like knowing like on my y-axis, are there increments of 2s? Are there increments of 5? How many bars? What are the relative heights? Axis labels. Oh, I'm loving this. This is great. And all the different kinds of graphs, like if they have axis labels, I absolutely agree with this. So using the bar graph, using different textures okay, so on bar graphs, are there different textures? Because that's exactly it. So like if there are different textures, we got to make sure that we know like which texture is representing what. And so the clock. So we're going to have numbers. We're going to have the hands and that like they're different like length of hands. One's going to be for the minute, one's going to be for the hour. Let's see what else we have here. Oh, so is it an open or closed full cell? I know this has got to be for number lines. I am loving this. Okay, one more, because I could spend all night doing this, just so you know. I'm loving this. Okay, so here's one for geometric shape. Number of edges, sharpness of angles, regularity of angles. So I like that. So going back like of those rays, how much space is between those 2 rays? How many edges are in that shape? Loving this. Okay. So the students have a hard time going across the graph to find the numbers. And I will tell you that I have seen that before. And I think a lot of that sometimes, especially is when it doesn't fall on a grid line. If they're grid lines and the grid lines really are tactually distinctive enough that they can follow them. But whenever they like go through another bar, that sometimes I kind of get a little bit like muddled with that. And so it's a lot of this practice. I'm also thinking that one time that I saw a teacher that she actually had her student use a ruler. And so they would put it at like the top of the line, and then they would like with the ruler, it would go all the way back, and it kind of helped them track back to the y-axis to be able to figure out what it was. And you could also even do that like when it's between. So are there ways? I saw somebody else, they used a wiki stick to kind of help them be able to go back. So lots of practice, but are there ways that we can kind of help them keep their hands going at the same level, going back and not dipping down or up? So thank you. Oh, so the dominoes, dividing line arrangements of the dots. That's totally it. Absolutely. So guiding the student to locations on a graphic. And so one thing, don't forget, y'all going to get all the chat. You just like 100 good ideas in our chat already, I think. So when you are guiding the student to a location on a graphic, you don't want to pick up the student's hand to move it. And instead, though, we have some ideas, is that perhaps use directional or positional words to describe where you want them to move their hand. Then sometimes you could point to the location with your hand and have them move their hand towards your hand. And that sometimes you might even like slide your hand under their hand and then you move your hand to the correct location, but you don't ever lift your hand from the page. And so what we want them to do though is we want them to notice where they are and where they should be. So this is a direct student quote that I think sums this up well. When you pick up my hand and move it, it's like dropping me off in the middle of a city and leaving me. Don't know where they kind of landed. So important information. And I was just on a meeting today about this, and we were talking about this, that sometimes our students, y'all just missed some really important information, like the title, that there's a key, that there's a transcriber's note. So yeah, that's why I'm always like, because I teach at the university, I'm always telling them like in preparation program that, hey, that make sure that, if you're going to have a transcriber's note, make sure there's some bang for your buck there, that they know that, oh, there's really important information. When I see a transcriber's note, I need to read it, because it really does though. It can give you like important information that if you miss, otherwise can make it really reading the graphic much more difficult. And so we gave you an example of one on the slide, and it's a graph of the system. So this is the one that the .5 prefix is omitted from the minus sign. So this must have been for UEB on the graph on the next page. And so if they hadn't read that, they might really be like, wait a minute, why is there not any .5? I think these were a minus sign, but are they really? So really important information in that transcriber's note. Title. Not every graphic has a title, but when they do, it's sometimes, as a matter of fact, very often, extremely useful. So they should be looking for a title if it exists, really before they dig into any other part of the graphic. So it gives context and it gives key information about the type of graphic. So even before you like scan that 15 seconds, if there's a title, you want them to find that title first. So a little bit about keys, that our students need to know that sometimes they're on the same page, but sometimes they're not. And especially like if you're taking a standardized test in Braille, sometimes they're on a facing page. And so I think it's really important that they get some chance to practice with that. You might have some in your books you can use. The one thing though is that they should always be before the graphic, but it gives the student information about what kind of area textures have been used, the line textures, what kind of points have been used, and if there are any kind of numeric or alphabetic abbreviations, it's going to help them. Transcriber's note. So it's really used to give key information. So sometimes it's just like general facts that it tells you, it just clarifies like the content of a graphic. So perhaps it explains like if there's a series of illustrations about what they're getting ready to have across several graphics. Or if they've actually made modifications, because if they left it just like it was, it wouldn't make sense in the tactographic. So maybe they needed to change something. Or maybe that they really needed to omit a couple of things because it really weren't relevant in that graphic. And so sometimes they just have a note telling them that they've omitted some of the information. But really, transcribers' notes are really essential, though, for understanding the graphic. And so anything we can do to encourage our students to read them, I'm all about it. So a scale. Now, you'll see scales a lot of times in maps, and there are times where we will see maps used along with scales in math, and usually it's because they want them to figure out some kind of information about the distance. So with the scale, is you want to, if they have a scale, you want to identify the scale if it is given. Sometimes it'll be along the x-axis and the y-axis. Sometimes it'll be in the key of a pictograph. I remember one pictograph that a student almost totally got back. I was like, wait a minute, do you think we should go back to the key? And then they're like, oh, wait a minute, every circle equals 2. And they're like, oh, wait a minute, everything I did, ah. So yeah, it's like, oh, that's really important information. On a number line, so it just kind of figure out whatever scale it is what is being used and for students to wear, because that will really help them make sure they're getting the right answer. So anchor points or reference points, I call them reference points, but I know sometimes people call them anchor points. And so with that, like there's a very, very teeny tiny anchor point in the triangle at the bottom left. And so if you keep your one hand there while you are counting the other sides, you know when you've got back to where you started. It's a great way to make sure that you get an accurate count of how many sides you have. And then if you have an array, especially like when they're just being introduced to multiplication, we'll see a lot of arrays just like this. But wait a minute, there are 5 rows and there are 4 columns. So 5 times 4 is 20. And then they can count and I'm like, wait a minute, that's exactly it. There are 20. And then like using the axis tick marks because they are also really important like reference points as well. So different types of lines, dotted lines, dashed lines, horizontal lines, vertical lines, diagonal lines, perpendicular lines, parallel lines, intersecting lines. There are a lot of lines in math. Straight, curvy, wavy, zigzag. Now, zigzag is one that I want to spend just a minute on because this is one that we don't always teach our students. But when you see a zigzag on like the y-axis, we have an example of a zigzag on the graphic. And so what that is saying though is that it actually that they have omitted numbers. It goes all the way from 0 to 160. So it's really important that students know what that zigzag means, that means they're omitting something. So lots of different lines for our students to explore. And so really important to track lines. And so I will say that we were talking about earlier, like with even like with the bar graphs, that when you're tracking your line, your grid lines back, that sometimes like there will be like, you know, a texture for another bar. And so like making sure that you keep that path. Sometimes it's also really good to give them lots of practice, especially following lines through intersections, because that can be a little challenging, but the more you do of it, I think the easier it gets. And then are there labels that can kind of give us some key information as we're tracking lines? So tracking along and between grid lines. So we have a bar graph, and this time some of the bars end on a grid line, but some do not. So you first of all have to know like what that scale is. So is it a scale as an increment? Is it going from in ones or twos or fives? Because knowing that's going to help you know, like estimate what that halfway between the scale marks are. And then you have to like examine, especially like if it's 5, and like, is it closer to the 10 or is it closer to the 5? And so this is just, I think, once again, that a lot of practice really helps our students become proficient. So different types of shapes. Interesting that there's actually like even like that when you look at the different orientations of a pepper, how it forms a very different shape each time. Some irregular shapes with this. So this is what I was talking about earlier about the different orientations of the same shapes. This is really important that our students have lots of practice. And then also that we give them plenty of practice with irregular shapes. The graphic on the right, there are several irregular shapes. So types of textures. So, at first, even sometimes just are they the same texture or are they different? Is it soft? Is it hard? And so can they describe like what they're feeling and are they able to distinguish? And so at first we really want to give them things that are textures that are very, very different before that we like introduce them to, I would say, like textures that don't have quite as much like easily recognizable textual differences. And then really being careful is that if I remember right from the guidelines, they say no more than like 5 textures on a graphic. And I will tell you, the more you get, it can be super hard to distinguish between them. So I understand why. I remember one time we saw a graphic where they had used like 8 different textures and some were very, very similar. I could see why students were struggling with it. So lead lines. Okay, so lead lines, first of all, should always be the less distinct of all the different lines, and they should be straight. And so what lead lines do is that they connect a label to a feature or an area on a diagram. And so what happens is sometimes there's just not really room for us to like write in Braille what it is. And so we have to use a lead line. So this is another one of those things that I think the more exposure that our students get helps. So I will tell you that the one that I think of immediately is that sometimes do students recognize that it is like the altitude or the height of a rectangle is what's being identified versus, or is it the hypotenuse? And so it's getting like, okay, let's feel the differences of where we might find these labels and what helps us know what's being labeled. So using the correct math vocabulary, whether we are saying diagonal, horizontal, vertical, parallel, perpendicular, these are all the different types of things that they are going to be using in math. And so it's really important that we are reinforcing that math vocabulary and that we're labeling them in ways that they're going to hear in the math room, because this will actually help them when they're hearing that language and then already being able to associate it with the graphics. So verifying and checking information, this is another one of those things that I think that students get better with it across time, but really encouraging them to go back and to double check their answers and ensure that they are accurate. So this is just one of those things, is like coming up with like very specific strategies for them to be able to go back. And I think sometimes, especially like when they find out, oh, wait a minute, I think I might have made a mistake, it kind of makes them a little more buy-in for the next time about verifying that information. So successful readers ask a variety of questions. And so we kind of listed out, if I remember right, probably about 15 different questions they asked. But it's really important is, where am I? Am I looking for a title? Am I scanning the whole graphic and the key? What's my point of reference going to be? Where am I going? What are my important clues? What are my prominent textures? What are my landmarks? What are my major? What are my minor lines? And what kind of point symbols are included on the graphic? So there's more questions that our successful readers ask. Leslie, go ahead and show us them. I know they're there. What am I looking for? Oh my goodness, that's exactly what am I looking for? So search the key in the graphic for detailed specific information. Read labels. What are the similarities and differences to other graphics I have explored? So what can I take from my previous experience to help me understand this graphic? And then how do all these pieces fit together? And so sometimes it's us asking our students the questions and then giving some of this information to them. So how do these pieces fit together? Okay, so now that we've kind of scanned it, let's look for like some specific answers, and then let's see if we can start putting that puzzle together. So this is going to be a really, okay, I don't know that we have time for the flood the chat.
No, I think we need to move past this one probably.
I'm so sorry. But we're going to think it is. Okay, one more. So sample of skills by concept category. So just think about how many concepts that our students really need to become familiar with related to size, to shape, and to texture. Whether it's big, little, small, thick, thin, wide, narrow, and that's just for size. Same thing for shapes, whether it's a line, it's circle, square, triangle, rectangle, diagonal, or diamond, sorry. And then texture, how does it feel? Is it smooth, rough, hard, soft, bumpy, or fuzzy? And so we're going to just round out the last couple of minutes with some examples of checklists and rubrics that you might be able to use to really kind of collect data as you're going along and show progress that your students making. So here is an example of a checklist you could use. So they read the title. They examined all sections of the graphic. They identified the graphic as a table or whatever it was supposed to be. That they identified that there were columns and rows for the two-column table. They interpreted the two-column table. They're able to create their own table. Or perhaps it's they identify the graphic as a pictograph. They're able to interpret the pictograph or create the pictograph. And so for whatever type of graph it is, that you can kind of come up with that checklist. So Sarah's going to round it out with some rubrics for us.
All right, you bet. Sometimes it's nice to have in one spot the different things that you're looking for as the student is exploring a particular graphic. So this is just a chart of skills where you can keep track of whether it is systematic when they're searching. Uh, are they rarely using systematic, or are they consistent with being intentional about where they're going on the graphic? And then having tally marks for the different shapes that might come up, and whether they're following those horizontally, vertically, etc. We've given you a sample rubric as well around graphing that gives more points based on being able to access more in the graphic. The next slide we have is just a link to resources for you to peruse on your own outside of this. Just some things that we put together in Iowa and some options that APH has on their website as well. So we've included these resources for you to use at your own leisure. And I just want to thank all of you again for being part of this webinar and looking forward to seeing you at our third.
Yeah, so if anybody has any questions, we just appreciate you hanging out with us. Thank you all. And thank you for being willing to share with us.
Well, what's the best font to use with the swell machine?
There is actually a swell font.
Yeah, it's 1229 or something.
What's it called? I tried to write it down last time and I didn't get it right. And do I have to purchase it?
What we'll do is we'll go ahead and link that in our resources after
Okay.
this meeting, and we'll put that in there.
Thank you. I appreciate that.
Oh,
Absolutely.
that's a great question because font really matters. So glad you're asking.
I made some graphics and I was told that the braille didn't look right on them. So, or
Yeah.
feel right. Yeah.
Ooh, someone just told us that a new APH product that may help with tactile graphics was just released called Memory Puzzle Shapes, a new tactile braille matching game designed for learners 3 and up. 52 waterproof puzzle pieces, uncontracted braille, and print labels. Tactile clues, a wavy orange line indicates horizontal direction. Square orange indicator in the top right corner of each tile. Introduction to geometry and spatial reasoning includes, wow, triangle, square, diamond, octagon, pentagon, star, chevron, trefoil, rhombus, pi, hexagon, polygon, etc. That's exciting. I'm going to check that out. And someone else is talking about the fonts. Yeah, at least 20, but I think it's like a swell 29. It may even be bigger than 20. And here's someone else. I found that I had to turn the temperature up. Now I have a P off, and I will tell you that it's a very fine line because if I don't have it hot enough, it doesn't like raise it enough. But if I turn it up all the way, I burn my graphic. So, yep. And then people come down saying, oh no, what's that smell? So I have to be really careful. It's a fine line. Anybody else have any questions? Oh, wait, we do have one here. A question from earlier. If you have a scatter plot with two categories of points, typically distinguished by color. What is the best way to distinguish them in a tactographic? Seems like different shapes for the points, but are there suggested contrasting shapes that are easily distinguishable?
The other thing I would say is um, if it is two colors that you could also use two textured, so one might be a dotted line and the other might be a solid line, would be another option as well. Sometimes it's nice if you have the different lines and you have a different symbol for points because it just helps to bring those together. Oh, no lines, just a scatter plot.
Yeah, if it's a
Yeah.
scatter plot. Yeah, so I'm trying to think, I'm pretty sure that I have seen it with different shapes, but the part about them is to make sure that they're really tactually distinctive, because I think that otherwise is challenging. Trying to remember, I think I saw it where one was more like circle and the other one was like triangles. Oh, absolutely. Oh, graphing art tape. I absolutely love graphing art tape. Oh, and then rubber bands and graphing boards are a great resource with push pins and graphing. Yeah, I totally agree. And the tactile graphic aid from APH
The
and
other
using
thing I
rubber
thought
bands.
about with the scatter plots is there is the graph benders where those points have a different texture on
Love.
top of the shape. So that texture can certainly help too.
That's a great idea. Love graph benders. Oh yeah. So someone else that you found at Art Supply. Yeah, I usually buy mine at the local art store for like less than $4. So yeah, I don't typically, yeah. I purchased it from the other company, but I usually get that from my local art store because it's a lot cheaper.
Yeah.
Oh, they discontinued the graphic art table. Well, it's a good thing that I have found it in other places. Woo. Oh, great. And Susan Osterhaus, you are an angel. She just gave them Appendix B has all the Braille fonts. Thank you, Susan. Oh, and someone else put in the link to Graph Benders. I will tell you that I am super excited. I use that product routinely. And then Susan's also given you a link to TSBVI where they have the font for free that you can download. Oh, and Amazon has graphic art taste. Amazon has everything. Why didn't I even think of that? Of course, I don't have to leave home. Thank you, EE. I'm going to have to check that out.
This is Leslie. I'm here. Why don't we wrap it up so folks can go and have their dinners and think about all the wonderful things that you've brought in. But thank you all for joining us. And thank you so much to Sarah and Tina for their extraordinary knowledge. And shout out to Susan Osterhaus, who's also on the team initiative. Um, thank you all for your wisdom. This is a wonderful group share and collaborative experience. We look forward to session 3 in a few weeks. Have a great night, and this will be posted as a recording along the PowerPoint's already there, along with the chat in just a few days. So you can go to the same landing page and then join us in a few weeks. Have a great night, everyone.
Thank you.
Thank
Thank you,
you.
Sarah. Thank you, Tina.